Alpha decays are kind of crazy. Two protons, two neutrons get ejected from the nucleus. Beta minus decays are crazier yet. There weren't any electrons in the nucleus, but a neutron mutated to create an electron and a proton, and the electron got ejected. Beta positive decays are even crazier yet. The logic in a beta positive decay is that the nucleus has too many protons. So to try and balance it out and try and become more comfortable, a proton changes into a neutron. The neutron stays in the nucleus. But to conserve mass and charge, that second particle has to have no mass, so it looks like an electron. And when I say no mass, relatively no mass, very light in comparison. So for mass-wise, it's light just like the electron is, but charge-wise, it's positive. Often in particle physics, it's called a positron. It is literally the antimatter twin to the electron. Antimatter is more commonplace now than it was even 2-3 years ago or 5 years ago. It's been around for a while. If you've ever heard of someone eating a PET scan, a PET scan, the P in PET scan stands for positron. I think it's positron emission topography, but the P is positron. It's used in medical scans. If we know that an element goes through a beta positive decay, just like the others, we can predict what it turns into, what the daughter is. We've talked about nitrogen a lot in chemistry class. Nitrogen, you can find it on the periodic table, has an atomic number of 7. When we did it in like grade 9 and grade 10 science, we always looked at the mass number. Nitrogen, you might remember because we used it quite a bunch. Normally we're used to it being 14. This time, this example I've made up though, we're looking at an isotope that's nitrogen 12. It's got 12 things in the nucleus, 7 of them are protons, so there's only 5 neutrons. This one breaks down, goes through a beta positive decay. Beta positives, they have a mass of 0. They're very light, just like an electron. For a beta positive, it's got a positive charge. To show that, we put a +1 down here. Really, if we think logically, what happened was one of the protons changed into a neutron and a positron. Since one of the protons changed, the daughter is going to have 1 less proton. In this case, it would have 6. The 1 and the 6 add up to make the 7 that we started off with. So this arithmetic and conservation still works. Mass-wise, we start off with nitrogen 12, so we end up still having a mass of 12. On the periodic table, or maybe you recognize this one, atomic number 6 is known as carbon. So basically what we've got here is a reaction where an unstable isotope of nitrogen decays into a stable form of carbon.